All right, next we're going to be learning about the segments of a circle. So we'll still deal with some things that have angle measurements, but primarily now we're looking at the measurements or the lengths of line segments. So circle conjecture number 10 says if two segments from the same external point are tangent to the circle, then the segments are congruent. All right, so here's my point of tangency. If I go ahead and draw the tangent line, and then here's another point of tangency, and I'm going to draw another tangent line. So if you can see, they are meeting at this external point. Here's our point of tangency, our other point of tangency. Then this segment right here and this segment right there are congruent. They are equal lengths. All right, so if we look at the first example here, it says the measure of angle ABC. So this angle right here is 65 degrees. And they want us to find the measure of angle ACB, and they want us to find the measure of angle BAC. So we have a point of tangency and a point of tangency in our two tangent lines. That means that this length and this length have to be congruent. And if the two sides are congruent, then that means that this is an isosceles triangle. And so this other base angle would be the same, 65 degrees, 65 degrees. And so then if we want to know what our third angle is, we could just say 180 degrees minus 65 minus 65, and that's going to give us 50 degrees. And so that means that angle BAC must be 50 degrees. Right. These problems are they're one of my favorites because they're so simple. So we have a point of tangency and a point of tangency. And so if this is 3, then this is 3. If that's 2, then this is 2. If that's 4, then this is 4. And they want us to solve for x. And so x is the sum of these two sides, which would mean that it is 6. So for this one, we've got 3 and 3. 5 and 5, 6 and 6. You can see that this is a triangle that is circumscribed about a circle. So circumscribed means it's on the outside. This one was a quadrilateral that is circumscribed about a circle. Here they want to know the perimeter of the triangle. So we have 3 plus 3 plus 5 plus 5 plus 6 plus 6. And that gives us a perimeter of 28. Number 4 is probably a little bit more exciting. So if we look at this one, this is using that idea that a point of tangency is going to be perpendicular to the radius that touches the point of tangency. So that means this is a 90-degree angle here. And that comes from the last set of notes as opposed to the set of notes that we're doing right now. And then if we look at this, I can see that this right here is a right triangle. So I'm going to go ahead and call, well, I know that's a radius of 5. I know this is also a radius of 5. But I'm going to go ahead and say that this entire thing is my hypotenuse. So I've got 5 squared plus 12 squared equals the hypotenuse squared. So 25 plus 144 equals h squared. So that means the hypotenuse is a length of 13. And so x plus 5 equals 13, and that means that x equals 8. All right, conjecture 11 says if two chords of the circle are congruent, then, let me zoom out, then their corresponding arcs, and here we're talking about the lengths of the arcs as opposed to the degree measure, the corresponding arcs are congruent as well. All right, so a chord, here's one chord, here's another chord. Let's pretend that those really are equal lengths. So if I say this is congruent to this, then the length of this arc is the same as the length of this arc. All right, so it says a polygon is inscribed, that means it's inside, so that each of its vertices lie on a circle, and they tell us that the polygon that we're putting inside is an equilateral triangle. So I'm going to do my best to draw a triangle with 3 equal sides. I think I kind of got it. And it says the triangle is JKL. So here's J, here's K, here's L, and it's an equilateral triangle, so we know that all of those side lengths of the triangle are the same. And all of these side lengths are actually chords of the circle, and so that means that this arc is the same as this arc, is the same as that arc. And now it wants us to name all the congruent minor arcs. So if you remember from our previous notes, a minor arc is an arc that is less than half the circle. And so J to K is a minor arc, and K to L is a minor arc, and L to J is a minor arc. And we know that since all of those chords were the same, all those arcs must be the same as well. All right, the next conjecture is that if a radius or a diameter of a circle is perpendicular to a chord, then it bisects the chord and its arc. And the word bisects, if you guys have forgotten from Math 2, means that it is cut in half. Perfectly in half. So not cut in two, but perfectly cut in half. All right, so I'm going to go ahead and draw. Here's my radius. And if I draw a chord that is perfectly perpendicular to that, then that means that it cut it in half. So this piece of the chord and this piece of the chord are exactly the same. And so that means that this arc and this arc are exactly the same. All right, so in this example, they tell us that OH and AT are perpendicular. So OH and AT, perpendicular. OT is a length of 10, so that means the radius of the circle is 10. OM is a length of 8, and they want us to find the length of AT. AT is that entire length. I'm going to go ahead and label this as X. So since these are perpendicular, that means that AT has been bisected. So that means that this length and this length are the same. So if this is X, then this has to be X as well. And if you look, you can actually see we've got a right triangle here. So I'm going to go ahead and use the Pythagorean Theorem. 8 squared plus x squared equals 10 squared. And I can minus the 64 over to the other side. And so x is a length of 6. And so that means that this is a length of 6, and so is this. And so that means that AT is a length of 12 altogether. All right, the next conjecture says if two chords in a circle are congruent, then they are equidistant, which means equal distance, and they are equidistant from the center. All right, so if I draw, here's one chord, here's another chord. I don't know, do you believe that those are the same size? Then if I draw, here's the center. Now when I want to find the distance from the center to the chord, then I need to draw the line that is the shortest, right? And so that's going to be like straight towards it, which means that these are going to have to be perpendicular. That's what that means. So if I draw, there's my shortest distance. So these are equal distance. It's equally distant from the center. And then these two chords are congruent. So I'm going to label that in the picture. I can't really put a tick mark because It's like they got cut in half, kind of congruent. Okay. So in example 7, it says MN is congruent to PQ. So they're telling you that the chords are congruent. And so that means that they are equally distant from the center. So that means that these two distances are the same as well. So OT is 3x and OS is x plus 15. So 3x, x plus 15. And they want us to solve for x. So I'm going to say 3x equals x plus 15. And I can go ahead and subtract the x over to the other side. So 2x equals 15. And so x equals 15 halves. Okay, we're working with the same picture. We're still talking about circle O, but we have some different information this time. So here they tell us that OT and OS are the same length, that they are 15. So we're saying these are the same. They're both a length of 15. So once we know that the two different chords are equal distance from the center, then we can say, oh, they must be congruent. So they're equal distance from the center, and we've got that 90-degree angle to show that it's like, it's not a diagonal distance, right? It's like the shortest distance there that we have. So they tell us that MN is 7x plus 13. And they tell us that PQ is 10x minus 8. And we know that those chords are the same. So I'm going to go ahead and set them equal to each other. And I'll go ahead and solve for x. So I can subtract 7x over to the other side. So 13 equals 3x minus 8. And then I'll go ahead and add 8 to the left side. So 21 equals 3x. And then I'll go ahead and divide by 3. And so x equals 7. Now that's not actually what they wanted to know in the circle. They wanted to know the length of the radius. So what I'm going to go ahead and do is I'm going to label some more things in our circle here. So if x is 7, then 10 times 7 is 70. 70 minus 8 is 62. So that means that this whole length right here is a length of 62. So we actually want to find the length of the radius. I'm going to go ahead and draw on this. So you can see here's the radius. Now I can draw the radius in the circle anywhere, but I picked right there because I have a right triangle right here. So if I go ahead and draw this right triangle, then I can go ahead and say that this is the 15 side. If the entire thing is 62, then that means that it's 31 and 31. So this is 31. And then this side represents the radius of the circle. So I actually have another right triangle going, and I can use the Pythagorean Theorem again. So you'll notice that when we talk about chords and tangents and things like that, we end up having perpendicular segments often, and that means we have a 90-degree angle. And so you'll find that we do a lot of right triangles when we practice these types of problems. So 15 squared plus 31 squared equals the radius squared. And so if you add these together, that's 1,186 equals r squared. And so r, I didn't simplify that. I just went ahead and plugged it in my calculator. R is 34.438. We'll go ahead and just leave it like that. Okay, one last example problem for this, and then we'll cut the video, do the rest in class. So it says if segment CD is congruent to segment DE, then that means that the arc has to be congruent to this arc. So then arc CD is congruent to arc DE. So if the segments are congruent, then the arcs must be congruent. If arc CD is congruent to arc DE, then now they want us to make a conclusion about this triangle right here. And if you guys remember from Math 2, for us to prove that triangles are congruent, we have to have some information. We have to have side angle side or angle side angle. or angle side, different things like that. So if this chord is the same, if this arc is the same as this arc, then that means that the angle across from it is going to be the same. So that means that these two angles are the same. And we have this right here is a radius to the circle, and so is this. So we know that this side and this side are the same. And then this side between the two triangles is a shared side. So now we have a side, side, side triangle, or we could say side, angle, side triangle. And so we do know that the two triangles are congruent, this triangle and this one down here. So PCD is going to be congruent to triangle PED. All right, next they say that DP is perpendicular to AB. So DP is perpendicular to AB. That means this is a right angle right here. Then the arc AD is going to be congruent to the arc BD. And that's because if you think about this, we know that the central angle is 90 degrees, and so this is going to be 90 degrees. That's 90 degrees, this is 90 degrees. And so if they're the same number of degrees in the same circle, then they're going to have the same lengths as well. All right, if arc AE is congruent to arc BC, so arc from A to E is this part right here, that is congruent from arc B to C right here, then the segment AE has to be congruent to the segment BC as well. So remember, if the segments are the same, then the arcs are the same. If the arcs are the same, it would make sense the segments would have to be the same as well. Next, it says that AB is perpendicular to CF. So there's CF right there. It says FG is congruent. And so here, this is the one where we're saying if a radius cuts into a chord and makes a perpendicular, makes a 90-degree angle there, then it bisects that chord. And so FG is congruent to CG. Okay, and then last, if arc AE is congruent to arc BC, so AE is congruent to BC again, then arc AC would have to be congruent to BE. And that's because from A to E is all of this, B to C is all of this. What they did is they said this part kind of overlaps between the two. They took that out. And so then this little piece and this little piece must be the same. All right, so that's it for our circle conjectures. I'll leave the rest of this for class since this video is very long.